Before we leave the safe harbor of Earth and plunge into the terrifying abyss of space, make sure you are ready for this flight. The universe is full of mysteries, and it is better to unravel them together. Right now, hit the subscribe button and activate the cosmic notification bell to become part of our crew and not miss the next expeditions beyond the event horizon. Your support is the main fuel for our travels. Fasten your seatbelts. Systems are normal. We are beginning the countdown. The boundless expanses of the universe harbor myriads of unsolved secrets. In the impenetrable cosmic darkness hide amazing objects, possessing sometimes completely inexplicable properties. Despite years of research, we have only slightly touched upon understanding the colossal diversity that surrounds us. Today we will set off on a fascinating expedition to the most secret corners of creation. Our path will begin next to the legendary Voyager spacecraft, which have been furrowing the expanses of space for decades. We will fly past our nearest stellar neighbors, including the Alpha Centauri system, and then plunge into the unexplored depths of the Milky Way in search of wandering rogue planets hidden in the gloom. Leaving millions of light years behind, we will see the majestic Andromeda galaxy, which has attracted the gaze of scientists for centuries. Our fantastic journey will continue through cosmic voids, where there is nothing but the echo of the Big Bang. Get ready, we are starting. On April 15th, 2021, the interplanetary station New Horizons made history as the fifth man-made object to cross the distance of 50 astronomical units from our luminary. Previously, this symbolic boundary was crossed by both Voyagers, and before them, the probes Pioneer 10 and Pioneer 11. It is likely that none of these cosmic wanderers will ever return to their native Earth. Some of them are still transmitting data, while others have fallen silent forever in the silence of space. Despite the fact that contact with some devices has been lost, the Voyagers continue to send unique information to Earth that overturns our ideas about the boundaries of the solar system. When these probes flew up to the heliopause, the conditional boundary where the solar wind collides with the powerful radiation of interstellar space, scientists expected to see a gradual fading of activity. However, the sensors recorded something completely different. Instead of emptiness and silence, the devices encountered an area of anomalously high temperature and plasma density. This discovery forced astrophysicists to revise models of how our star interacts with the rest of the galaxy. It turns out that the solar system is surrounded by a kind of wall of fire, a giant barrier of scorching plasma that serves as a shield for the inner planets. The temperature in this zone reaches tens of thousands of degrees, but due to the extremely low density of matter, the device itself did not melt. This barrier holds back a significant part of the destructive cosmic radiation, allowing life on Earth to develop in relative safety. The Voyagers literally pierced this protective shell, emerging into the open, unshielded ocean of interstellar space, where completely different physical conditions reign. Now that the protection is left behind, an unimaginable abyss lies before these man-made wanderers. The next major object on their path will be the Oort cloud, a giant sphere of ice blocks and comets surrounding our system. But even at a speed of 17 kilometers per second, Voyager 1 will take about 300 years just to reach its inner boundary, and another 30,000 years to cross it completely. This journey through time and space demonstrates the true, frightening scale of the universe, where human life is just an instant flash. Leaving behind the icy kingdom of the Oort cloud, we find ourselves in the true interstellar void. Here reigns the great silence. Our next target is located at a distance of more than 4 light years, the Alpha Centauri system. To realize this scale, imagine, if our sun were the size of a tennis ball in Moscow, then the nearest star to it would be the same ball somewhere in Vladivostok. We are crossing this colossal ocean of vacuum, where even atoms of matter are extremely rare, and the only companions remain distant photons of ancient light. Approaching the destination, we see that Alpha Centauri is not a lonely star, but a complex gravitational dance of 3 luminaries. 2 of them, Alpha Centauri A and B, circle in an eternal waltz, shining like our sun. But our attention is riveted to their smaller brother, the dim red dwarf Proxima Centauri. It is here, in the orbit of this small star, that a world hides that has excited the minds of all mankind. The exoplanet Proxima b a potential twin of Earth located in the habitable zone. If we were to descend to the surface of Proxima b, a landscape completely alien to the earthly, would open up before us. The sky here is likely painted in eternal twilight tones or flooded with a crimson glow. The planet's native sun hangs as a huge red disk on the horizon, flooding the rocky wastelands with infrared light. However, this beauty is deceptive and dangerous. Proxima is a star with a nasty character. It regularly emits powerful flares of radiation capable of blowing away the atmosphere and sterilizing the surface, turning the dream of life into a struggle for survival. Leaving the vicinity of the nearest stars, we enter a zone of absolute unknowns. In the deep gloom between star systems hide the ghosts of the Milky Way, rogue planets. These are cosmic outcasts, thrown from their native nests by monstrous gravitational forces at the dawn of the formation of planetary systems. There are billions of them, and they drift in total darkness, invisible to telescopes, until they block the light of a distant star. They are lonely wanderers, fettered by eternal ice, traveling through the void without a goal or route. Imagine what it is like to stand on the surface of a world where the sun never rises. There is no day or night here, only eternal midnight under the dome of an incredibly bright starry sky that never goes out. But even in this icy crypt, life is possible. Scientists believe that under the thick shells of ice of such planets, warm oceans may be preserved, heated by the decay of radioactive elements in the core. There, in complete isolation, ecosystems could have developed that do not even suspect the existence of light and the universe outside their water world. We accelerate, leaving these lonely wanderers behind, and the scale changes. Before us unfolds the giant spiral of our home, the Milky Way. This is a colossal city of 200 billion stars revolving around a single center. And in the very heart of this splendor, hidden behind dense clouds of dust and gas, lurks the dark queen of our galaxy, the supermassive black hole Sagittarius A star. This gravitational monster with a mass of 4 million suns conducts the movement of the entire galaxy, devouring any matter that has the imprudence to come too close. But it is time for us to move on, beyond the gravitational shackles of our home. We leave the Milky Way and break into intergalactic space. Looking back, we see our galaxy in all its grandeur, a shining disk surrounded by a dim halo of ancient stars and dark matter. Now an abyss of a completely different scale lies before us. Distances here are measured in millions of light years, and even light takes eternities to overcome this void. We are entering the local group of galaxies, where gravity binds us to our most formidable neighbor. Straight ahead, like a giant eye in the darkness, the Andromeda galaxy grows. This is the closest major spiral galaxy to us, and it is truly colossal. Andromeda contains over 1 trillion stars, twice as many as our Milky Way. For hundreds of years, it has attracted the eyes of earthly astronomers, first as a foggy speck, and now as a majestic structure flying towards us. This is not just a neighbor. This is a predator that is inexorably closing the distance, moving at a speed of 110 kilometers per second. The gravitational embrace of these two titans is inevitable. In 4 to 5 billion years, the Milky Way and Andromeda will collide in a grandiose cosmic dance. This will not be a head-on impact in the usual sense. The distances between stars are so great that collisions of luminaries are unlikely. Instead, the galaxies will pass through each other, their shapes will be distorted, the arms will be torn apart, and eventually, they will merge into one giant elliptical galaxy, Multiverse. The night sky of Earth in that era, if it still exists, will be illuminated by the light of trillions of new stars. Leaving the limits of our future united home, we realize that even the Milky Way and Andromeda are just tiny grains of sand in the grandiose structure of the universe. We are part of the Virgo cluster, a giant metropolis of galaxies. Here, thousands of star islands are connected by invisible threads of gravity, forming a single cluster. If you look at this from the side, the universe ceases to seem like a chaotic scattering of stars. It acquires a structure resembling the neural network of the human brain or the root system of a gigantic tree, where every glowing point is a home for billions of worlds. However, Even this cluster is only a small part of something truly gigantic. In 2014, astronomers found out that we live inside Laniakea, which means immeasurable heavens in Hawaiian. This supercluster of galaxies stretches for 520 million light-years. Imagine endless rivers of galaxies flowing through space, drawn by the attraction to a mysterious gravitational center known as the Great Attractor. We are all just specks of dust in this stream, rushing at a speed of hundreds of kilometers per second in an unknown direction. But the universe consists not only of light and matter. Between the shining threads of this cosmic web, frightening voids gape. These are colossal areas of absolute gloom, where not a single galaxy may be encountered for millions of light-years. We are diving into the Boötes void, often called the Great Void. Its diameter is almost 330 million light-years. If the Milky Way were in the center of this void, we would have learned about the existence of other galaxies only in the 1960s, when sufficiently powerful telescopes appeared. To the naked eye, the sky there would be perfectly black. We continue our movement through the fabric of space-time, rushing to the very boundaries of visible existence. The further we look into the abyss, the deeper we plunge into the past. Light takes billions of years to bring us images of these distant worlds. Now we are observing galaxies as they were at the dawn of creation, young, furious, and chaotic. We are approaching the cosmological horizon, the limit beyond which the human eye cannot penetrate because the light from there simply has not had time to reach us since the birth of the world. And here before us arises the last, insurmountable wall, cosmic microwave background radiation. This is the oldest light that is possible to see, a kind of baby photo of our universe, taken just 380,000 years after the Big Bang. Before this moment, the cosmos was a glowing, opaque soup of plasma that did not let a single ray through. This faint, cooled microwave glow permeates every cubic centimeter of space around us. It is the echo of a grandiose birth, the fading trace of that primordial fire from which everything arose, from atoms to stars, from planets to you and me. Our journey is coming to an end, but the history of the universe continues. Every second, space inexorably expands, pulling galaxies further and further apart under the influence of mysterious dark energy. In the incredibly distant future, the sky overhead will become empty. Stars will exhaust their fuel and go out one by one. The last black holes will evaporate, and the universe will plunge into eternal cold and absolute darkness. This is the probable finale, heat death. But until this moment comes, we, tiny observers on a small blue planet, continue to look up, trying to unravel the greatest mysteries of this infinity. But what if what we see, stars, nebulae, galaxies, is just the tip of the iceberg? Modern science claims that the matter familiar to us makes up only 5% of the content of the universe. The rest is hidden in the gloom. We call this dark matter, the invisible scaffolding of creation. It does not emit or reflect light. It passes through us right now without leaving a trace. We know of its existence only by its gravitational shadow. Without its additional mass, galaxies, including our Milky Way, would simply crumble apart like sandcastles in the wind due to the enormous speed of their rotation. An even more mysterious force came into play about 5 billion years ago. Astronomers discovered that the expansion of the universe is not slowing down as expected, but on the contrary, it is accelerating. Some unknown energy, named dark energy, is literally blowing up space itself, pushing galaxies apart with increasing speed. This is a force of anti-gravity, the nature of which is absolutely unknown to us. It occupies almost 70% of all the energy of the cosmos, and ultimately, it is what may lead to the Big Rip scenario, when space stretches so much that even the bonds within atoms will be torn apart. However, even these frightening prospects may be only part of a much more grandiose picture. Inflation theory and string theory lead physicists to the thought that our universe is not the only one. Perhaps we live in a multiverse, where our world is just one of an infinite number of bubbles floating in a boundless quantum ocean. In each such bubble, completely different laws of physics may operate. Somewhere gravity is weaker, somewhere light moves slower, and somewhere life is impossible in principle. If this is true, then the end of our universe does not mean the end of everything that exists. It is just the completion of one chapter in the infinite book of being. Looking at this unimaginable grandeur and infinite number of worlds, we inevitably face the most frightening question of modern astronomy. Where is everyone? This is the Fermi paradox. Given the age of the universe and billions of Earth-like planets, the cosmos should be teeming with life. We should see traces of giant astroengineering structures, catch signals of alien civilizations. But instead, our radio telescopes catch only white noise and cold silence. This silence may be the loudest sound in the universe, hinting that intelligent life is a phenomenon so rare and fragile that we may be the only conscious observers in this galaxy. There is a frightening theory of the Great Filter, which states that on the path of development of any civilization, there is a certain insurmountable barrier that destroys life before it can conquer the stars. Perhaps we have already passed it, becoming a lucky exception. Or maybe this filter is still ahead, in the form of nuclear war, artificial intelligence, or ecological catastrophe. This places a colossal responsibility on humanity. If we disappear, the universe may again plunge into the oblivion of silence, where there will be no one to admire its beauty and solve its riddles. We are the eyes of the universe through which it looks at itself. We are stardust that has gained reason. Our journey from caves to the craters of Mars is just a moment on the cosmic clock, but it is this moment that fills the cold void with meaning. Regardless of whether we are alone or not, whether the cosmos has an edge or is infinite, our goal remains the same: to go forward, beyond the horizon, to where the maps end. Because as long as we ask questions and strive for the stars, the history of the universe continues. And it is being written by us right now. Among the cosmic zoo exist objects whose very existence defies common sense. Imagine a star that is heavier than our sun but compressed to the size of a small city, for example, Moscow or New York. These are neutron stars, the superdense remains of perished giants. A teaspoon of the substance of such an object weighs 1 billion tons, as much as Mount Everest weighs. Some of them rotate at a crazy speed, making hundreds of revolutions per second and emitting narrow beams of radiation like cosmic lighthouses. We call them pulsars. If you were nearby, gravity would tear you into atoms instantly, before you even had time to blink. But even pulsars pale before their even more terrible brethren, magnetars. These are the strongest magnets in the universe. Their magnetic field is trillions of times more powerful than Earth's. If a magnetar flew into our solar system and stopped at the distance of the moon, it would not just wipe information from all credit cards on Earth. It would pull the iron out of your blood and tear apart the molecular bonds of all living things. Sometimes starquakes occur on their surface, releasing as much energy in a fraction of a second as our sun produces in 100,000 years. If we look into the farthest corners of space, we will see ancient monsters that perished long ago, but their light has only just reached us. These are quasars, the active nuclei of young galaxies. In their center sit supermassive black holes that devour matter with such an appetite that the gas surrounding them heats up and glows brighter than thousands of galaxies put together. Quasars are the brightest objects in the universe. Some of them eject jets of plasma, jets, for millions of light years, burning through intergalactic space like cosmic blasters. All these natural phenomena demonstrate colossal energies that humanity can only dream of for now. Russian astrophysicist Nikolai Kardashev proposed a scale of civilization development. We, humans, have not yet reached even the first level. A Type 1 civilization uses all the energy of its planet. We control only crumbs, burning fossil fuels. A Type 2 civilization is capable of harnessing the energy of its star entirely. And a Type 3 civilization becomes the master of an entire galaxy, drawing energy from billions of stars and black holes. We are at the very beginning of this path, at a level of about 0.7. What might the engineering of gods look like? One of the hypothetical projects of a Type 2 civilization is a Dyson sphere. This is a giant shell or swarm of satellites completely surrounding a star to collect 100% of its radiation. If we built such a thing around the sun, we would have so much energy that we could dismantle the other planets for building materials or create a giant laser to communicate with other worlds. Astronomers have already noticed stars with strange, irregular flickering, for example, Tabby's star, and some seriously ask the question, are we seeing an unfinished Dyson sphere of an alien civilization? But even with infinite energy, we remain prisoners of the speed of light. The nearest stars are years of travel away, and galaxies are millions of years away. To become a true galactic civilization, we need to learn to cheat physics. The concept of a warp drive, or Alcubierre bubble, implies not moving through space, but moving space itself. By compressing space in front of the ship and expanding it behind, we could travel faster than light without formally violating Einstein's laws. The ship would stand still inside the bubble while the universe rushes by. There is another theoretical way to cheat space, a wormhole or Einstein-Rosen bridge. Imagine the universe as a flat sheet of paper. Instead of crawling along the surface from one edge to the other for millennia, you fold the sheet in half and pierce it through. This is a tunnel through the very fabric of reality, instantly connecting two infinitely distant points. In theory, entering such a portal, you could exit in another galaxy or even in another era. However, physics is inexorable. To keep the throat of such a tunnel open and prevent it from collapsing, exotic matter with negative energy is required, which we do not yet know how to create. But any games with gravity and superluminal speeds have their terrible price. Einstein proved that time is not a constant. The stronger the gravity or the higher your speed, the slower time flows for you. This is gravitational time dilation. If you risk approaching the event horizon of a supermassive black hole, only hours will pass for you, but centuries will fly by on Earth. Returning home young, you will find the ruins of cities and the graves of great-grandchildren. A journey to the stars is always a tragedy. It is a ticket to the future, but without the possibility of returning to your past, to those you loved. Looking at the frightening mathematical perfection of the laws of physics, some scientists ask perhaps the most provocative question of modern times. Is all this real? The simulation hypothesis suggests that our universe is not base reality, but a complex computer program run by a superintelligence. Arguments in favor of this include the oddities of quantum mechanics. Particles behave in a certain way only when they are observed. This suspiciously resembles optimization in video games, where the world is rendered only where the player looks to save the system's computing power. If we are not living in a simulation, then how do we explain the fact that we exist at all? Perhaps the answer lies not on Earth, but in the icy wanderers furrowing the void. The theory of panspermia suggests that life did not originate in our oceans, but arrived from outside. Asteroids and comets that bombarded the young Earth billions of years ago could have carried seeds of life, complex organic molecules, and amino acids frozen in ice. In that case, we are all aliens. We are descendants of ancient cosmic biology that travels from star to star, taking root where conditions allow it to bloom. But we are cramped in our cradle. Humanity's gaze has long been riveted to Mars, our red neighbor. It is a rusty, cold desert where dust storms of planetary scale rage. But this is the only place we can escape to if Earth becomes uninhabitable. The dream of terraforming Mars, turning it into a second Earth, is one of the most ambitious ideas of our species. We will have to melt the polar caps to return the oceans and create a thick atmosphere to protect against radiation. This is work for centuries, but the first step has already been taken. Our robots are already there, leaving will tracks in the red dust. However, life may hide not only on planets, but also on their moons. Look at Europa, a moon of Jupiter, or Enceladus, a moon of Saturn. On the outside, these are dead ice balls fettered by cosmic cold. But under their multi-kilometer crust hide global oceans of liquid water, warmed by the gravitational tide of gas giants. There is more water there than in all the oceans of Earth. Probes have already recorded geysers bursting through cracks in the ice. It is quite possible that right now, in the absolute darkness of these subglacial seas, creatures swim that have never seen the stars but live off the heat of hydrothermal vents. In our solar system, there is another place that frighteningly resembles Earth, but in a twisted, toxic mirror. This is Titan, Saturn's largest moon. It is the only world other than ours where rivers and seas splash on the surface. But flowing in them is not water, but liquid methane and ethane. It rains hydrocarbons here, and the atmosphere is so dense and orange that Saturn is almost invisible from the surface. Gravity here is weak, and the air is thick. A person, strapping artificial wings to their arms, could fly here like a bird over endless dunes of ice sand, were it not for the frost at -180 degrees. But no matter how far we fly, we will always remember where our home is. However, Earth has an expiration date, and it depends directly on the Sun. Our star is not eternal. In 5 billion years, the hydrogen fuel in the core will run out, and the Sun will begin to die. It will turn into a red giant, swelling to monstrous sizes. Its outer shell will swallow Mercury and Venus, and then reach Earth. The oceans will boil away, the atmosphere will burn, and our blue planet will turn into a charred rock rotating inside the hot atmosphere of a dying star. This is the inevitable finale of our history in this system. Space is not only slow processes of decay, but also instant catastrophes. The most terrible sniper of the universe is gamma-ray bursts. They arise during the collapse of massive stars into black holes. This is a narrowly focused beam of pure energy that releases as much light in a few seconds as the Sun will produce in its entire life. If such a beam, released from a distant galaxy, accidentally hits Earth, it will instantly destroy the ozone layer. The beam itself won't burn us, but without ozone, solar radiation will sterilize the surface of the planet, killing all living things. And the scariest thing is, we won't see its approach, as it moves at the speed of light. In the mathematical equations of general relativity, there exists another ghostly object that no one has ever seen, but which theoretically must exist. This is a white hole. If a black hole is an abyss from which it is impossible to escape, then a white hole is an object into which it is impossible to enter. It works on exhale, continuously expelling matter and energy into space, and nothing, not even light, can penetrate inside it from the outside. Some physicists boldly suggest that the Big Bang itself was the moment of birth of a giant white hole, from which our universe poured out. Let's return to where we started, to the Voyagers. Attached to their board is perhaps humanity's most touching artifact, the Golden Record. This is a message in a bottle thrown into the cosmic ocean. Recorded on the gold-plated disc are the sounds of Earth, the sound of rain, the beating of a human heart, laughter, a child's cry, and greetings in 55 languages. Also encrypted there are the coordinates of our Sun relative to pulsars and a diagram of a human. This disk is designed to last 1 billion years. Most likely, it will outlive Earth itself and become the only monument that we once existed, dreamed, and loved. To truly realize how young we are, let's compress the history of the universe into 1 calendar year. The Big Bang happens in the first second of January 1st. The Milky Way forms only in May. Our Sun and Earth appear only in September. Primitive life in the oceans originates at the end of September, but crawls onto land only in mid-December. Dinosaurs rule the planet from December 25th and die out on the 30th. And all of humanity? We appear on this stage on December 31st, a few minutes before midnight. All recorded history, all kings and wars. These are the last 14 seconds of the cosmic year. But what will happen in the next year? Physicists' predictions for the distant future chill the blood. In trillions of years, when the last red dwarfs go out, the Degenerate era will arrive. Only cooled cinders of stars, brown dwarfs, and black holes will remain in the universe. But even dead matter is not eternal. Theories predict proton decay. The very matter of which planets and remnants of ships consist will begin to crumble into elementary particles. All solid objects will simply dissolve into the void, leaving behind only a rarefied gas of leptons and photons. At the very end, after a googol years, a 1 followed by 100 zeros, even supermassive black holes will evaporate. This phenomenon is called Hawking radiation. The last black hole will disappear in a bright flash, and the universe will plunge into a state of maximum entropy. It will be an eternal, unchanging, cold soup of photons with a huge wavelength. Time will lose meaning because nothing more will happen. Space will become an infinite graveyard of light, where not a single star will ever be born again, and not a single thought will arise. And yet, these gloomy pictures are just forecasts based on our current, limited knowledge. Perhaps the universe is cyclical. The Big Bounce theory states that expansion will be replaced by contraction, and everything will return to a single point to explode with a new Big Bang, giving birth to a new universe with new laws. Or maybe intelligent life, having reached a divine level of technology, will find a way to restart the stars or create a new bubble of reality, escaping from a dying world. We don't know the finale of this play because we are still in the first act. For now, we are here. We are the cosmos' way of knowing itself. We are created from the stardust of exploded luminaries, and now this dust has gained consciousness to look at the sky and ask, who am I? Our curiosity, our striving for the horizon, our telescopes and rockets. This is not just a whim. It is the instinct of life itself, striving to break out of its cradle. And as long as at least one person looks at the stars with awe, the universe is filled with meaning. The exploration continues.
Thank you for subscribing.